Thank you very much. Due to cold, my voice is choken up, so maybe I'll try my level best. Uh, so today I'm going to talk on XSS and CSRF with HTML5. HTML5 specification has been changed and it's evolving. So we are seeing some new way or new openings for XSS and CSRF. So we are going to pretty much covering that in this particular talk. My brief introduction has been given, so I will skip this. Starting with HTML5 vector attack surface. So what we have is, if you go out and search there are numerous new vectors which are added on the browser surface with HTML5. So one of the survey which was done by ENISA, which have taken around 13 specifications and tried to threat model them, and they were able to find around 51 security possible weaknesses in HTML5 specification. And pretty much new vectors which are evolving, malwares are attacking it, and so on. So pretty much a lot of things which are happening in HTML5, and pretty much all the browsers which you are using right now, be it Chrome, Safari, IE, etc., are HTML5 enabled already. So if you briefly look at the HTML5 evolution, so pretty much HTML started in 1991, but major breakthrough came in 2005 when we started to look at XHR, XML HTTP request object being introduced, and at that point onwards, we have various different technologies evolving like AJAX and RIA and so on. What had happened in 2009 with HTML5 specifications that started to come in, browser started to implement these HTML5 specification, and has changed completely the browser attack surface. So if we look at broadly current modern browser architecture, what we have is a core policies layer here, where the policies which are quite a new policies which are added, like we have a SOP, that's a same origin policy. Now on top of it, we have something called CORS, cross-origin resource sharing policy. We have another policy called CSP, that's a content security policy, and something new which is added called sandbox. So when you do iframe, you can use a sandbox attribute to iframe iframe into a sandbox. So there are some bypasses, there are some issues with this policy in the specs, or you can say there are some checks and balances which can be bypassed since feature required. So we'll discuss that, and pretty much a course is a policy which is pretty much going to be used by XHR when it comes to do CSRF or when it comes to do a cross-origin call. So that's the major change. On a network services, what we had is browser native calls where we are passing values by name value pairs. And then we have a plugin socket, and these are the two new sockets which are added in HTML5 specs. One is called WebSockets, and another is called XHR level 2. So we had XML HTTP request object level 1, and with this, what we have is a XHR level 2. So we'll look at XHR level 2 in detail as well. But XHR level 2 is essentially a tunnel which gives you a cross-origin tunnel, which allows you to do a CSRF. So that's the one thing which is added. And all these features are essentially can be coded into your JavaScript, and through JavaScript you are calling these calls. So that's the network access layer. On top of it, when it comes to a process and logic layer, where your core client-side application would be running. So we had a JavaScript. Now what we have is a DOM, which is now specification or DOM4, which is a very powerful specification which is out there for document object model, which has plenty of new events added in this layer as well. One more thing which is added in HTML5 is called threads. We never had a threads in a JavaScript. Now what we have is something called web workers. So through web workers, you can spin threads. You say, okay, load the page and start these 7 threads at the background, which are running. Someone is fetching your Twitter account, someone is going out and fetching your mails and so on. Apart from these little buckets which you are seeing, which are very interesting, what we have is a web SQL. So now you can have a client-side web SQL in terms of web SQL or IndexedDB. So you can run or store data on your browser using WebSQL and indexing. You can have cache. That is a client-side cache, which you can store. Like we have a server-side cache. Now, a web application can tell browser that store this data as a cache. We have a file system. You can have a full-fledged file system, a virtual file system in your browser. So you can create files, you can delete files, whatnot. And you have a storage. We never had a storage in your browser. You always had a cookie which can store some information. Now what we have is a local storage and a session storage which can be stored. So pretty much if you look at all this stuff, your browser is like emerging as a mini OS. It's no longer a thin client. So what had happened is like we are going back to the past where we had using a thick client to communicate with the backend. Now cloud would be our backend and browser is emerging as a thick client. On top of it, what you have is HTML, CSS tags. Now with HTML5, the tags are not static. Each tag has API. So for example, if you take a video tag has APIs. If you take audio tag, it has APIs. So these tags, HTML tags are no longer tags. They are tags plus API. And we have Silverlight and Flash, which used to run. Pretty much what have happened is the Silverlight and Flash is fading out and HTML5 is taking over the browser side of the application. So this is how modern browser looks like. On top of it, what we have is HTML5 is not restricted to just the browser. It can run on any of mobile devices as well. So pretty much HTML5 surface is both on browsers and mobile applications. Now, moving to the server side of application. So what we have is a server-side HTML5 application architecture is being changed. So what we have here is your application which runs on a sandbox, which is pretty much bounded by same origin policy. What you have is HTML, CSS here. You have a JavaScript running here, and then everything which you are doing with the document object model. Now, these applications are not a traditional application which runs on multiple DOMs. These application runs on a single DOM. So when you make a request to a slash page, the slash page will send you a bundle of tags, a bundle of JavaScript, bundle of JavaScript libraries, and then throughout your application, it is going to remain on a slash page only. So that's why HTML5 applications are broadly known as a single DOM application or single page application. That's why how the architecture is designed. So pretty much once you have this, your application would have a storage, WebSQL, IndexedDB, etc. And on top of it, you have a database messaging API, geolocation API, XHR, WebSocket, and native sockets. And then you connect to internet and then access your application. So now if you look at a few demos here. So for example, if we open these applications over here. So this application, which is a typical store, for example, a web store, but it's created in HTML5. So it's a single page application. Now you start clicking all these different things. We can use a Chrome dev toolbar to see what is going on. Now, Chrome bar has something interesting called resources. So you can see what resources this particular application is using, and you can see some unique things like WebSQL and IndexedDB and a local storage and so on. So these are the HTML5 components which you are seeing here. Okay. So pretty much it has a local database where a local catalog has been created, which you are seeing over here. It's not, you don't have to go and make a backend call. It's just grabbing content from your database locally. Now we just browse through the application. It has created local storage, hash, IDs, and so on, which are part of the local storage here. So it is creating all these different applications and entities over here. Now if we go and place an orders, for example, and we go and try to see IndexedDB database, for example. So it has something called IndexedDB, and these are tokens which are set on IndexedDB over here, and so on. So all these different features which are on a single DOM, which are leveraged. Now over here you can see it is creating a file system. So if you do a file system : HTTP, whatever IP you are on to it, and then say temporary or permanent, what kind of a file system, a virtual file system which is created on your browser. So this application has created a temporary file system, for example. So we say temporary files, and you can see the whole file system. So this is like a virtual file system which is created in your browser. This is not a server-side file system, this is a browser-side file system. So pretty much all these features, and then you are using jQuery, and you're using JSON objects to communicate with the backend, you are using XML and so on. So this is how a typical application of HTML5 would look like. Now this is not just restricted to browser. It is pretty much applicable to mobile devices as well. So if you create same application in a mobile device, so one, you definitely create and consume this application in your mobile browsers or regular browsers over here. You're using mobile jQuery here for mobile application development. You have single DOM, which is running in your browser, which is running again on a mobile. You have a login, logout, etc. All these features which are typical application, it is using local storage and so on. So that is how this application will work. You can open in your browser, which is on a mobile device. And on top of it, interestingly, what you can do here is you can create a hybrid application. So hybrid application is the way how mobile is going forward. So when you create a hybrid application, what you're doing is part of your code, which is in a native language, which would be maybe Android or iPhone, iOS, and then part of the other application is actually HTML5. So that's how hybrid application can be created. So over here, for example, this is a hybrid application which you create. So you don't have any bar on the top, address bar on the top, but everything can happen in your hybrid application. So this is how pretty much your hybrid application can be created in HTML5. Now, when it comes to these applications and we want to assess, audit these applications, we need a different approach because now everything is happening through JavaScript. So we want to control what JavaScripts are doing. So one of the things which we have done during our assessments and audits, which we do to WASP, is that we have to figure out, there are, say for example, you load a page, and as soon as you load a page, it may happen that you get, 90,000 of JavaScript, for example. 5 libraries are loaded. 3 customized JavaScript .js files are loaded. So now what we want to do is, when you do a particular event, you want to see which lines of JavaScript are being executed. So we wrote a simple tool called DOM Tracer, which we now have from our site, which is a plugin to Firefox. So what you can do is you do your assessment and keeping DOM Tracer on. So it will show you it's like a JavaScript sniffer in your browser, which will show you which JavaScripts are being executed. So say for example, the CM application which we crawl or assess through our DOM Tracer. So what we have over here is we have this plugin called DOM Tracer, which we started here, and we'll browse this HTML5 application. And over here we have some kind of a rule set, which we can pass on as a regular expression, where we say, okay, show me all IndexedDB call, show me all local storage call, show me all WebSockets and so on. So you will see all the calls which are interesting from HTML5 perspective. If a regular expression matches, we'll get a 3 arrow against that particular line. So if we do this, pretty much all these calls which you can see. So we start clicking these links, and as we start links, we'll see the JavaScripts or a line of JavaScript which are executed in the DOM. So for example, we got this line here, which is clearly a window request file system there, a file system, a local file system in your browser, which is being created. So pretty much you can see all these HTML5 calls. For example, local storage over here, which we can see. We keep on browsing on this different page and we harvest all HTML5 features. Session storage is being used here. This is doing a web SQL transaction and so on. Now we move to some other pages like a login. It again created a file system, new order. It has created IndexedDB. So this is an IndexedDB being created in your browser and so on. So this is pretty much a feature which required when we do assessment with HTML5 application, because we need to figure out what is going at the back. Now CSRF, we'll first attack CSRF and try to see what is the impact which we have with CSRF and HTML5. So typical CSRF is pretty simple. We have a client, we have a attacker site, and we have a target web store. So over here, client log into the application in a web store, and we get a success over here. A cookie has been set. Now the client is visiting the attacker site. So attacker site will send a CSRF payload, which initiate a CSRF attack, and that attack will go to the web store. What is going to happen is, in this particular attack, browser is designed in such a way that it will replay the cookie. So cookie will get replayed, and without the consent or knowledge of the victim, he has actually placed an order or CSRF attack and been successfully added. So two things which are happening over here. When a CSRF goes in, two things happen. One, you bypass the SOP because same origin policy is bypassed. You are on a foo.com page load, which is coming from foo1.com, is changing something on foo.com. So that is a one. And second is your cookie being replayed. So then when your HTTP request goes to the target domain, it knows the identity. So when these two things are successful, a CSRF attack will kick in. And traditionally, browser has tags like img, script, iframe, and so on, which allows you to do a SOP bypass. So say, for example, you are on yahoo.com, and you can load an image file from google.com, or you can load an iframe from google.com. So these are the GET requests, HTTP GET request. Now you can do a POST request as well. You can create a dummy form, and then through a JavaScript, you click a form button. So that will generate a POST request. So these are the traditional CSRF, which we all know. Now, with HTML5, what is happening is that HTML5 or Web 2.0 as well, is that our pipe is no longer traditional. So we are not sending name value pair and expecting HTML to come back. What we are doing is we are sending JS array, we are sending JS object, JS array, XML, and JSON. So then we need to do a CSRF on all these different streams. So pretty much another approach which you can take is you split your inputs. So for example, if I want to do a CSRF on XML stream, what I do is I create a dummy form, and a form would have action tag. So action tag is SOP bypass. So it will generate a request to that. And half of my XML would be on name and half of it will be on value. And when a JavaScript, you do a document by.submit, what is going to happen is it will generate a POST request on the server and put equal to sign in between, and you will see a nice XML envelope. So this is like a second generation CSRF attack. Now, with XHR level 2, all these things are pretty much become very easy. We'll see why. So now what we have is XHR level 2, and we are attacking CORS or SOP. So with XHR level 2, what we have is XHR level 2 call is very powerful. The XHR object is very powerful. So XHR is no longer a text only. You can pretty much send text, array buffer, document, blob, binary, and so on. So the first thing is using XHR, now pretty much you can send any data across the sockets. That's number one. Now XHR level 2 has ingredients for SSF, CSRF. So for example, you have a cross domain which is possible. So say for example, if you take XHR level 1, so I'm on yahoo.com and XHR object is coming from yahoo.com and it's XHR level 1 object. And I use that object to create a domain connection to http.google.com. It will fail. It will say you can't using XHR level 1 object, you can't do this. But with XHR level 2, this has been allowed. So now pretty much you can do using XHR level 2, you can communicate with the cross domain, provided you follow CORS. So CORS is a cross-origin resource sharing policy, and the policy is being implemented in such a way that it will do a pre-flight negotiation before making the actual HTTP call. So it has added extra headers like this. So it has added HTTP request headers. Over here, like access control request method, access control request header, access control allow origin, access control allow credentials, and so on. So for example, if I'm on yahoo.com and I want to make a request to google.com using XHR level 2, when I make a request, first I have to do a pre-flight negotiation. And Google will say me that whether I'm allowing to make post request with XML JSON to the domain or not. And if it say yes, then whatever content coming back will get loaded in my browser. So for request and response, what is going to happen is before you make a call, there is an option call which will go through on the wire. That is a pre-flight call. So CSRF powered by course and XHR, and it's allow a still channel. Now this with XHR, you can open a still channel against the backend. And then you can do both post and a get, and then pretty much you can send any data to the cross domain. Now, some interesting catches over here. The first thing is, if you set your content type on XHR to text plain, then there is no pre-flight. So you can simply send that request cross domain. There is no pre-flight constraint there. And if you set your with credential to true, cookie will automatically replay over XHR. So pretty much by using this, we can do a cross-domain call. We can bypass pre-flight, call will go to the cross-domain, and a cookie will replay. Now, if a server side is validating the content type, then there will be a protection. But if it's not doing the validation, then pretty much this attack vector will go through. And a lot of different sites which look for the right JSON. As soon as they have a right JSON, they will start processing it. They will not see the content type header before processing it. And you can do a still browser if I want to allow all the browsers to call back and talk with me. What I can do is every request I can say allow origin to start. So then the cross domain will actually talk with me. So this can be used for the payload mechanism if you want to open a still channel. And then pretty much after that, you can do binary uploads. You can use a binary content to ship in and so on. So attack vector will go through in this particular fashion. For example, you have a web store here. You have a client over here. Client will do a login over HTTPS. The login will go through. You will do a session cookie authentication. Now browser will actually use XHR. This is the way how application is defined. So browser will send a JSON services. There is a JSON services. So browser will send JSON traffic, and since a cookie will replay, it will go through. Now, a browser is going to some attacker site. So attacker site will send a payload, which is coming from there, and it will have a content type set to text plain and with credential true. So in this case, what is going to happen is it will initiate a connection. The payload like this or a script like this. What we have done is we have opened a post connection to cross domain. We have set a header to text plain here, and we have set a credential to true here. So if this in this particular case, and as you can see over here, we can send pretty much anything. Over here it's a JSON. We can send XML. We can send binary traffic, whatever we want to send. Pretty much we can send anything. So this will actually open a connection to your web store here, and without the victim's consent or notice, still HTTP request generated, silent exploitation will take place, and pretty much the attack vector will go through. So this is how pretty much it's possible to do a CSRF over here. So for example, right now you can see we are on 100.21 domain. So this is our target domain, and when we place an order for a particular product over here, so a cookie will replay, and we'll get these kind of HTTP requests over here. So let me make HTTP request here. We click on these JSON requests. So we have a JSON services, which is running at the back end. And we get this kind of stream, which is going in. So now this is not a traditional stream. This is JSON stream or XML stream or so on. And we get a JSON response back. So this is how a typical functionality which is being implemented. So now we go to this site, which is completely different domain over here, which is 100.6, which can be completely separate. Over here now we are opening a connection to 21, content type text plain, credential to true, and then we are placing an order on behalf of that gentleman who is on that site. So now if we click this link and look at the traffic, what has happened? So we click the link. Before clicking the link, we'll just look at the traffic here. So now page is loaded. Now we click on go button here, and you can see all HTTP requests will pop up here. So this is the request, a post request, which was generated, and a post request will have JSON and a cookie is being replayed. The only change is the content type is text plain over here. So if a server or server-side API or JSON is not validating this, then the attack vector will go through. So this is our typical CSRF with HTML5 stream. So another interesting thing is with XHR, you can generate a multi-part request as well, which is a multi-part request which usually generated when you do upload. So for example, you have a functionality like this over here where you're uploading the file. You say, okay, click upload, upload the file. Now when you do uploading the file, your bulk order will get uploaded and you get a success over here. And when you send this request, the request would look like this. This is a multi-part request. Multi-part form, you have a boundary, and then your request is going through. Now you visit attacker site, and when you go there, attacker can create a file, which is a multi-part file through JavaScript. So there is no actual file. It is just a file which is created dynamically through JavaScript. And that file will get open a connection, upload the file, and you get a success over here. So for example, if we generate a script like this over here, so what we have is we create a stream or a file on the fly, which can be binary, which can be XML, which can be JSON, anything which you want to create. And then you open a connection, you set a multi-part form, and then you send this request, and the actual request will go through. And without the person's notice, the multi-part request will fire up, it will upload the file. So for example, using this, someone has demo that you can change, for example, an image file. You have a profile, and you have an image file on your profile, and you visit the attacker page, and your profile, your image on the profile will get changed. So multi-part was not possible with XHR level 1, now it's possible. So pretty much these are the few changes which have come through. Another interesting thing, or another extension to CSRF possible is something called cross-domain response extraction. So say for example, when we talk about CSRF, we can send requests. We can't get access to a response. That's how a CSRF usually works. But with this, what you can do is pretty much attacker can't come through a firewall into your internal systems over here. But attacker can send a page to your browser. Now your browser is sitting on these network. Now your browser can scan all these different applications which are running on your internal network. Now any of these applications would have a cross-origin stand to start. So pretty much they have allowed these particular, say for example, your internal mail is fine if these applications access the resource. Then in that case, what can happen is you don't only send CSRF, but you can start crawling these sites as well, internal sites. So that is like a cross-origin response extraction, which is also possible. So for example, over here, using XHR, what we can do is we can do an internal port scan. Say, okay, which ports on your internal systems are open. Now when we find any of these ports, what we can do is we can check whether access control allow origin is set to star or not, whether it's set to true or not. If it's true, then what you're doing is you can start crawling that site, that internal site. So you have a significant amount of, if your cross-origin policy is not set right, then pretty much you have an exposure where a web page can start crawling your internal networks. So for example, here is an example of a simple one, 100.6 for example. You visit a page, and that page will start doing a simple port scanning here. So it say, okay, let me do a port scan. So it will go out and scanning the ports internally and looking for wherever we get cross-origin access. So over here, for example, 100.21 give us a cross-origin. The policy on this particular resource is set to start. So now next step, you don't do a CSRF, but you do a cross-origin response extraction as well. So now if we go ahead and start sending this particular request, what have happened is not only we send HTTP request, we inside our DOM we got the response as well. So now we have these handles in our DOM which can send these response wherever it wants to send. So pretty much over here on 100.21 we actually extracted the content from the DOM. So that is also possible with this when your policies are not set in right fashion. So pretty much when you look at your HTTP request, you can see access control allow origin set to start. So all these are possible with pretty much with the CSRF. So how you defend with CSRF? Scan, look for content type checking, look for your cost policy, form and upload tokens. So when you're doing a form-based processing or when you're doing some kind of uploading, make sure that you have some kind of a tokens in place. Secure libraries for HTML5 and that 2.0 streaming, CSRF protection, and strong cost implementation. So this is how pretty much CSRF has evolved with XHR level 2 and HTML5. Still these course stacks are being returned and browsers are implementing in different way. So for example, recently I've observed that with the Chrome, with a multi-part, you can't do a cookie replay and so on. So these features are still evolving and some countermeasures will definitely kick in. So that's the one part. The second is talking about the cross-site scripting with HTML5. So pretty much with the cross-site scripting, you have HTML5 and CSS and the JavaScript which you're typing. What we have is we have a lot of different new tags which are added with HTML5. So you have tags like media, audio, canvas, embed buttons. You have attributes like font, submit, sandbox, and so on. And then you have drag, drop APIs, push state, and so on. So pretty much if you have a filter which is doing some kind of a typical reflection and persistent XSS, and if these filters doesn't have these tags in their blacklist, then pretty much this will allow you to do a cross-site scripting. For example, over here, we are using video tag for on error and popping up. Over here, we are using alert with autofocus, key gen, text area, select input, and over here we have a form ID. So there is a very nice cheat sheet out there called HTML5sec.org, which has a compilation of all these different tags, all these different values, which can be added to your blacklist. So that is possible. Now, another thing which you have here is when, say for example, you are getting exploited in HTML5 browser. So what is going to happen is over here, for example, so for example, you have a reflected cross-site scripting. So you get a reflected XSS over here. The problem with the reflected XSS is once you move from that page to another page on the same domain, that XSS will stop executing because you are moved to another page. So over here, for example, what we are doing here is XSS, for example, a typical XSS which you can find here on this particular place. And this is a sample code over here. So what we are doing is we can load the file, we can load the page or a payload on same domain over here. So we are pointing to 100.21. And then we are injecting the iframe using a sandbox attribute. So there is a sandbox attribute in HTML5 which allows you to load the same origin page, and then pretty much what you can do is you can start communicating at the back end wherever you have some kind of a listener running. And when you set up this, you set up access control allow origin to start. So that particular JavaScript will talk with you. Now over here, you can see we are setting the 100.21, and then we are setting up some kind of iframe here. So iframe. On these iframe, what we have at the end is this block. So sandbox attribute in the iframe, and we are saying allow origin to start, allow forms, and allow scripts. Now what is going to happen is when you allow origin, your iframe DOM can be extracted by your payload, which is sitting in between. So now, whenever you move or whatever you're doing, what kind of activity you are doing on that particular application, you can actually can monitor. And another HTML5 API which is out there, which is called push state history, history push state API. This particular API will allow you to change the address bar as well. So pretty much this attack vector will actually become very stable. So now if we go ahead and inject this little vector here, and we are listening for whatever activity which is happening on the top. So we found XSS on the search page, and this is our node JS, which is running as our backend listener. We start that. So we are listening for traffic, and we can send our payload here. So now on the search box, we say script src equal to the page and search. Now what have happened is we are listening. So iframe, which is loaded on top, which you can't see right now, and the same page has been loaded here. So now till the guy is on this particular domain, whatever is happening we can see at the back end. So now, for example, the guy is moving to, say, login page. Now you can see over here, the address bar is being changed, because with the push state we can tunnel the page. And now as soon as we enter a username and password or any keystrokes, or for example we are watching a part of the DOM which we are observing over here. So as soon as over here, for example, goes and enters a username and password, any inputs which the guy is entering, we're just trying to monitor that in our payload. So that you can see over here. Foo, so we can see foo here, and whatever password being entered. Yeah. So there are some features which are added in HTML5, like sandbox and so on, which allows some kind of a exploitation as well, if a coding is not done in right fashion. So pretty much what you can do is choking down your reflected and persistent XSS and doing a blacklist, improve your blacklist and so on. Another interesting defense which is added with HTML5 is a content security policy. So what we have is the content security policy. It's a base is SOP. It's the same original policy as its base, and it dictates what you can do and what you can't do. So for example, when an application sends HTTP response, it can send the policy using, for example, you have a Safari or a Chrome browser. You can set with x/webkit.-csp. If you have a Firefox, then X content security policy, and so on. So this will actually dictate what scripts you can run, what you can't run, and so on. So say, for example, if you do a script src self, then what is going to happen is, if you are on a foo.com, only foo.com can pass you a script which runs in your browser. So even you get XSS, even you get exploited, and if someone wants to send a beef payload from foo.com, that payload will not come and run, because that's how a browser will decide. So browser will say, foo.com has told me that not to run scripts from other domain. So very interesting factor, CSP has been added. And you can tighten, if you want to tighten CSP by not allowing inline script as well. On top of it, you can pretty much, using CSP, you can decide connect SRC as well. Say, for example, you have XHR, and you want to say, XHR object can connect to just self back. It can't connect to this or that side. Frame SRC, object SRC, media SRC, default SRC, where you can say, okay, my connection has to be HTTPS and so on. So this is a very nice countermeasures which is added for cross-site scripting as well. Say, for example, you can say that if even I am cross-site scripted, my object cannot be loaded from anywhere else. So you can dictate object SRC as well. Say, for example, over here we have a persistent XSS, and as soon as we have a persistent XSS and we have kit SRC, script SRC set to self, right? And I try to load a beef payload from my target machine. So it will not get loaded, you will get these kind of error back. It's a content security policy directive. As a script SRC self, I will not load this particular script. So pretty much a new openings are happening at the same time some new security mechanisms are coming in. So this is about XSS, and now along with XSS, what we have is several different types of HTML5 features which can be exploited as well. So say, for example, one of them is a web storage. So now what we have is with HTML5, you have some kind of a storage API. So storage API allows you to do store data locally in your browser, and it can be a local storage or a session storage. So for example, you can use a local storage and set some kind of a hash here. Now, if I want to audit the page or site, what I can do is I can run this kind of a loop, which will go and open all the objects, and if I find a local storage object, it will actually harvest this. So these kind of payloads can be crafted and sent, which will allow you to extract this. So if you're storing anything in a local storage, which is in clear text, it's unencrypted, then pretty much if you get XSS, these content can be very easily can be shipped back. So pretty much over here, for example, this particular application is you log in and you open up here. You send this kind of a payload here, for example. Let's say, okay, run through the loop and send me back the values which you find from the local storage. So this is what you're sending here. You start this. So you're on 100.4. You're running this listener, and we run this. Sorry. So we take the value. So if you run this, you can see over here, in this particular application DOM, I stored something in local storage, which you can see over here, hash. So now this particular value can be extracted by any process scripting as such. So now if we send payload here, so this is a place where we found XSS. Now instead of this, we say load this page. And then we'll take the hash value and send to the site. So that's another feature, which is a local storage. Another one is a file system. So pretty much you can create a file system on the fly, and pretty much this is a way how a developer can create a virtual file system in the browser. So this file system, which is a temporary file system, which is created. This is the typical JavaScript. For example, a token file is created. Some kind of a tokens are stored. If you do a file system local storage, you can see this file. And if you get XSS, you send this payload, and pretty much this file, the whole file system can be extracted. So as I said in the beginning, that HTML5 browsers are no longer a thin browser. They are like mini OS. So it's like a small OS which you are exploiting, running threads, exploiting file systems, exploiting local storage, and so on. Another interesting one is if you analyze these single DOM applications, they have lots and lots of global variables, and global variables are stored and permanently there. So if you get a DOM-based XSS, for example, then DOM-based XSS can start harvesting this global variables. And the global variables would have values like email, passwords, or your hashes, and so on. So pretty much you can run these kind of a loop and see all these global variables. So these global variables have more information than anything else. So pretty much if during the XSS days where we are doing a traditional XSS, we look for cookie all the time. Like if we get a cookie, that's great. But these are the variables which have very strong, which have information about the cross domains as well. So if you go out and run these global variable search on your application, you will see how many global variables are created and so on. So you can scan for this. Another one is a web SQL. So pretty much if you have created a web SQL, then pretty much we have a server-side SQL injection. Now these are the ways you can do a client-side SQL injection, a blind client-side SQL injection. You run these JavaScript and it will say, okay, this particular page has one database, and then you get the database name, and then from the SQL master, you get the name, and then you run this particular script, you get the item name. So there is an item table, and then do 1 or 1 equal to 1, or just extract it. So it's possible. Another interesting feature with HTML5 is called web messaging and workers. So this is very interesting because we never had a messaging system within our browser. For example, if we load 2 iframes, and these 2 iframes wants to talk with one another, then we can't do that. You have to send all the message back to the server, and server will talk back. But with web workers, what we have is we have something called post message call. So with the post message call, you can load up JavaScript and fire 5 or 6 threads at the back end, and then talk with these threads using post message. So if your post message is set to start, then pretty much you are listening for anyone to listen this message. So say, for example, that particular page is being iframed, then the parent can start talking with your object. So in this case, pretty much inner HTML and eval calls, which if you're using between your threads, then that can create a DOM-based XSS. So one of the checks which we usually put is check your origin before you initiate the post message from where you come. So pretty much all these different things are out, and this is in var worker, create a new worker, and a worker will start a JavaScript at the back end and start processing as a thread. And whenever you want to talk with this thread, you say worker.postMessage, and you will start like typical threads which we are talking. So web workers will get loaded, and talking over here, you have a web page, and one of the good thing is web worker cannot access your parent DOM. So if you've got the XSS running in your web worker, you don't get the parent DOM. Other than that, pretty much you get all the features of regular application. So security issues are pretty much a DOM-based XSS. So for example, over here, we create a thread over here, and say message.js, where we are listening our messages. And then whenever a new message comes, we'll read the message. But you can see this call. This call is inner HTML call, and loading these new data, which is coming as a message. So then pretty much what can happen is this message has an XSS payload, which will actually execute it in your browser. So if you go back over here, there is a little widget, which is HTML5 widget, which is listening for these messages at the background. The thread has been started. So now we say, okay, get my last message. We say read last message, and message comes, and as you do a click, JavaScript get executed. Over here, as you can see, a get element. Over here, the message has been created. You have 2 commands implemented. Here is your thread, and then here is your inner HTML call. So web work is possible to, if a poor programming practice being used in this particular cases, would allow you to do a cross-site scripting. So pretty much all the features which is using HTML5, you have to make sure DOM calls go safe, take care of eval and document.write calls, and so on. This is just a scratch on the surface. There are many more APIs out there with HTML5, file API, drag and drop API, and so on. So all these different APIs can be exploited as well. So as we go, we'll learn more about HTML5. This is like pretty brief on HTML5. So these are some of the resources and references. Very nice HTML5rocks.com. If you go there, very interesting material there. We are running on OWASP. We are running the HTML5 cheat sheet, where I'm contributing as well. So you have OWASP stuff. This is a quick cheat sheet. HTML5security.org has all the resources compiled on HTML5. And Koto's blog, very interesting work being done by this gentleman. And you can find his blog entries, which talks a lot about HTML5. So that's pretty much it from my side. I do blogs, so you can visit my blog. Whatever I discuss, everything is blogged there as well. You can email me, and pretty much the tools which we have discussed, like DOM Tracer and DOM Scan and so on, you can find on blueinfy.com. So that's pretty much a conclusion. Thank you very much for listening.